When we observe planets, stars, and galaxies, we look back in time because of how long it takes for light from celestial objects to reach Earth. Have you ever looked up at the night sky and wondered why we could only see in the past? It's a mystery that has puzzled humans for centuries. How can we look back in time when we look into the stars? To understand this phenomenon, knowing a little bit about how light works and how far away those stars are is essential. In today's video, we will explore why we can only see the past when looking at the stars and demystify this cosmic mystery once and for all. Please give this video a thumbs up and subscribe to this channel for more stuff before we continue. To sign up for new video alerts, click the bell icon. Have you already implemented it? Let us move on. We look into the past when we look up at the stars. These far-off objects ignited their light years, decades, or millennia ago, and now it enters our eyes. When we look at something up there, we see it as it was in the past. Professional astronomers can see far more than most backyard telescopes thanks to enormous modern telescopes and sensitive detectors. By gazing at the stars, how far can we see? The stars in our galaxy rarely experience the kind of event you imagine. This is because while our galaxy is 100,000 light-years across, most stars have ages measured in millions or billions of years. The light's journey to us takes only a tiny portion of the stellar lifetime. You must see a star getting close to the end of its life for this event to happen. Betelgeuse in the constellation of Orion is one such object. It is a vast supergiant that could be living out its final 100,000 years. However, since it is only 700 light-years away, there is a slim chance that the explosion has already occurred, and the light has already arrived. However, it is your best chance to see the parent star of a now-dead star with the naked eye. However, if you travel further to objects in other galaxies, this problem arises. It is believed that gamma-ray bursts indicate the demise of highly massive stars. They are visible in galaxies that are billions of light-years away, but the stars that gave rise to them may have only had 1,000,000 years to live. In these instances, even with powerful telescopes, we cannot see the long-dead star that exploded. At a distance of millions of light-years, we can observe with telescopes the brightest massive stars in other nearby galaxies like Andromeda. These stars have lifetimes of a few million years, so they likely have already exploded as supernovae, but we still see them as they were. How can we look back in time by observing far-off galaxies? In actuality, telescopes are not looking back in time when they observe the light from distant galaxies. No one can directly look at the past because it no longer exists. Instead, the telescopes are observing a beam of light's current pattern. The beam of light has been largely undisturbed for millions of years as it moves through the empty space vacuum. As a result, the pattern of this light beam at present is the same as the pattern it had when it was first produced by the far-off galaxy millions of years ago. We can therefore guess the galaxy's appearance millions of years ago by observing a beam of light in its current state. As the light has not yet changed over time, the current light beams striking telescopes pointed at far-off galaxies only to provide information about the past. A more accurate representation of the past would result from the light from distant galaxies changing as it travels, but this change would have to be in ways we can comprehend and subtract from. The redshift that results from the universe's expansion is one significant alteration to light as it passes through intergalactic space. Light waves are stretched and end up with more extended wavelength components as they move through space, which is itself expanding. Longer wavelengths cause the entire light pattern to be shifted toward the visible spectrum color red. Because it is redder, the current bundle of light that is detected by a telescope differs slightly from the appearance of the distant galaxy that produced it millions of years ago. Fortunately, since the redshift is now well understood, it is possible to shift the light pattern back to the proper amount to produce an accurate representation of the distant galaxy when the light was emitted. The universe is mostly empty, so light can travel a long way without hitting anything, and distant galaxies are so far away that their light takes millions of years to travel the distance in a straight line. These two factors allow light from distant galaxies to travel unhindered for millions of years. The tools used to research the past. The Hubble Ultra Deep Field is the image chosen for this leg of our journey, UDF. The UDF is among the most profound views of the universe that have been created to date. It was undoubtedly the deepest when it was first developed in 2003-2004. The UDF has a roughly 13 billion year history, approximately 400 and 800 million years after the Big Bang. Galaxies from that period would have been very young and very different from the large spiral galaxies we see today in structure and appearance. Astronomers have discovered a population of 7 primitive galaxies that were previously unknown and formed more than 13 billion years ago when the universe was only 4% as old as it is today. The first statistically sound sample of galaxies that tells how numerous they were close to the time when galaxies first formed is produced by Hubble's most profound images to date. The outcomes come from an ambitious Hubble survey of the ultra-deep field, an area of the sky that has been extensively studied, UDF. A team of astronomers led by Richard Ellis of the California Institute of Technology in Pasadena used Hubble's Wide Field Camera 3, WFC3, during the 2012 campaign, known as UDF-12, to look farther into space in near-infrared light than ever before. The observations were made over 6 weeks in August and September, and the initial research findings are now being published in several academic papers. After preparing them for use by other research teams, the UDF-12 team makes these detailed data available to the general public. Finding out how quickly the number of galaxies increased over time in the early universe was one of the main objectives of the new program. This measurement is the primary indicator of how quickly galaxies assemble their star-making components. By examining the colors of the galaxies through a carefully selected set of 4 filters at specific near-infrared wavelengths, the team could determine the distances between them. James Dunlop of the Institute of Astronomy at the University of Edinburgh in Scotland, a team member, explained that in order to conclusively rule out the possibility that some of our galaxies might be foreground objects, we added one filter and undertook much deeper exposures in some filters than in earlier work. Whether hot stars and such early galaxies could have produced enough radiation to warm the cold hydrogen that formed shortly after the Big Bang has been a subject of much debate among astronomers. It's believed that this reionization process occurred between 200 million and 1 billion years after the universe was born. Astronomers can now see far into the past thanks to this process that rendered the universe transparent to light. In a recent study, galaxies are observed in this early period. In conclusion, it is essential to remember that when looking at the stars, we see a glimpse into our past's fantastic and expansive universe. The light from the stars has traveled billions of miles in order for us to see it, but this does not diminish its beauty or mystique. Whether you take a moment to admire their brilliance or look through a telescope for an even clearer view, looking up at the night sky can be both awe-inspiring and humbling. The video for today is over. If you liked the video, please subscribe to the channel and give it a thumbs up. Remember to click the bell icon to get alerts when new videos are posted. Until then, bye. I will see you in the next video.